Okay, people. So we finally arrive at final chapter of ITT 440 network programming. So parallel programming in Python. So last chapter 8. So we used to know how to what is parallel programming and parallel processing. Right. So we will move to the final chapter. That is apply the programming. Okay, using Python language. Okay, the content outline is thread versus processes, parallel versus concurrent, and lastly the Python parallel programming ecosystem. By the end of the lesson, students should be able to understand the basic concept of CPU hyperthreading, and students should be able to write parallel programming in Python. Okay, so we take a look thread versus process. Alright, so if we notice here the logo here, okay, Pentium 4 is more show the HT, okay, the HT at the logo. So hyperthreading. Okay, hyperthreading was Intel first attempt to bring parallel computation to consumer PCs. It departed on desktop CPUs with a Pentium 4 HT back in 2002, 20 years ago kan. Okay, single physical CPU core with hyperthreading appears as two logical CPUs to an operating system. So while the operating system sees two CPUs for each core, the actual CPU hardware only has a single set of execution resources for each core. Sebenarnya ada satu je kan. Okay, tapi dia akan nampak sebagai dua. Right, so hyperthreading allows the two logical CPU cores to share physical execution resources. So hyperthreading can help speed your system up, but it's nowhere near as good as having actual additional core. Kan? Kalau you pakai Intel i3 ada dual core, so it's lagi baguslah daripada HT kan. Tapi kalau kita dah ada multiple core dengan HT, dia double up lah kan, lagi bagus lah. Okay, multiple cores, we go to multiple cores. Original CPU had a single core, so that means the physical CPU had a single central processing unit on it. So to increase performance, manufacturers add additional cores or central processing unit, or we call CPU. So dulu sebelum saya belajar diploma sains komputer ni, kalau saya sebut CPU tu dia punya casing dia kan, casing CPU tu kan kita panggil CPU. Okay, right. So bila belajar rupanya CPU ni dalam microprocessor. Tapi bila lama-lama orang nak sebut CPU, masih lagi orang nak sebut CPU yang casing dia kan, dia punya kotak tu kan. So saya tak kisahlah kan, tak adalah kata bukan, itu bukan CPU dalam dia, tak perlu cakap macam tu lah. Kan kita kita raikan je lah kan, macam orang cakap dah pakai dah makan Maggi ke apa kan, Maggi tu jenama kan, mi segera, takkan kita nak betulkan kan. Biarlah. Okay, tak perlu betul pun sebab dia dah jadi common lah. Okay, common understanding. Alright. To increase performance, multiprocessor add additional cores or central processing units. Okay, so a dual core CPU has two central processing units, so it appears to the operating system as two CPUs. A CPU with two cores, for example, could run two different processes at the same time. So this speed up your system because your computer can do multiple things at once. So a dual core CPU literally has two central processing units on the CPU chip. So kalau a quad core pula has 4 central processing units, ada 4. Okay, sama juga ada octa core, ada 8, ada 6 core kan. Alright. So in hyperthreading, the operating system is tricked into sync to CPUs for each actual CPU core. Okay, there are no trick on multiple core. A dual core CPU literally has 2 central processing units on CPU chip. A quad core CPU has 4 central processing units, and octa core CPU has 8 central processing units, and so on. So modern CPU now have both multiple core and hyperthreading technology. So dual core CPU with hyperthreading appear as 4 core to your operating system. So hyperthreading is no substitute for additional core, but a dual core CPU with hyperthreading should perform better than a dual core CPU without hyperthreading. Tak perlu nak banding-banding lah. Dan better ada dua-dua lagi bagus. Okay, how threads work? So a thread is the unit of execution within a process. So a process can have anywhere from just one thread to many threads. Sebab proses pun dia dah bagi kepada banyak thread. That's why kita boleh guna hyperthreading walaupun kita tak ada physically ada dua core atau multiple core yang lain kan. Alright, so kita boleh buat hyperthreading. Nampak macam ada dua core juga. So, programs are typically stored on disk or in non-volatile memory in a form that can be executed by your computer. So, the program has been loaded into the computer's memory in binary form, and executing program needs more than just the binary code that tells the computer what to do. The program needs memory and various operating system resources in order to run. A process is what we call a program that has been loaded into memory along with all the resources it needs to operate. Right. So, the difference between thread and process. So, ini cerita balik ni. Betul ni? Thread dengan proses mana lebih besar? Okay. Betul lah. Okay. Thread is lighter weight operation. Process is heavy weight operation. Thread use the memory of the process they belong to, but process has its own memory space. So inter-thread communication can be faster than IPC. IPC is low kan. So context switching between thread of the same process is less expensive, but context switching between processes is more expensive. So threads share memory with other thread of the same process, tapi process don't share memory with other process. Kan? That's why kita perlukan IPC kan? Inter-process communication. Right. So salah satu adalah shared memory lah kan. Okay. Senang nak faham tu.